determinants. Myself, Aftab Bhai. So, let us proceed. What do you mean by determinant? Determinants are the scalar quantities obtained by the sum of products of the elements of a square matrix and their cofactors according to a prescribed rule. So, here friends, there are few things that we need to remember when we are speaking about determinants. The first point is that it is a scalar quantity, and I have told you in my previous sessions what is scalar quantity. Scalar quantity is matlab it is a single number. Determinants are a single number. And how is it obtained? It is obtained by sum of products. So, what do you mean by sum of products? Product matlab we are multiplying two numbers and these two numbers are multiplied, that is the products, and when you add it up it becomes sum of products of the elements of a square matrix. So, here one important thing is when we speak about determinants, we can find the determinants only for a square matrix. It can be a 2 by 2 matrix or else it can be a 3 by 3 matrix, and they are cofactors. So, this particular word cofactors come into the picture when we are speaking about 3 by 3 matrix. So, and according to a prescribed rule. So, in my next slide we will be seeing what is the rule. So, these are few important things that we need to keep in mind when we are speaking about determinants. First is determinants are a scalar quantity, which means it is a single number obtained by sum of products, that is when we are multiplying two numbers, a different set of numbers, and then adding it up together, of what type of matrix? Of a square matrix. So, this is the second important thing, it should be a square matrix. Third important thing, and it has a prescribed rule, that is the fourth important point that we need to remember. Then this is the basic of determinant. Then what is actually the meaning of determinant intuitively? So, the determinant of a square matrix is a single number, already it has been told, it is a single number. Here I am writing it single number, here I have written it as a scalar quantity that among other things can be related to, this is the important part, area, volume of a particular region. So, determinant shows geometrically the area of a region, or else you can say the volume of a region. So, here friends, when you speak about this is a square thing. So, what is the area of this square thing? So, here it is two dimensional. So, we call it as area, but if the same thing becomes three dimensional, then we call it as volume. So, here three dimensional. So, here we say area and here we say volume. So, this is what is determinant means geometrically. It represents the area of a region when we are speaking about 2 by 2 matrix, or else it represents the volume of a region when we are speaking about 3 by 3 matrix. Next is determinants. Where do we use determinants? Friends, determinants are used, first point that is related to us for our syllabus is we can find inverse of the matrix, and these are the topics that we are going to deal it in the coming days. So, first, where do we use determinants? We use it to find the inverse of the matrix, and we also use it to solve linear equations. So, these are the two important areas where we make use of determinants. Moving ahead, how do we denote determinants? Determinant of a matrix A is denoted as DET, determinant, inside the bracket A, that is the matrix, or simply determinant A without the bracket, or A written in the form of modulus. So, this has nothing to do with the word modulus, it is just it is a straight line bracket where we are writing A. So, this is the fundamental meaning, usage and denotion of determinants. Now let us go ahead and see the determinant of different dimensions of matrix. So let us start with the first dimension. What will be the determinant of a 1 by 1 matrix? 1 by 1 matrix matlab one row and one column. And here you can see if A is a matrix which is having a single number, so here the row is 1 and the column is also 1. So the determinant of this particular matrix is the number itself, that is determinant of 3 is 3. Similarly, determinant of -5, what it will be? Determinant of -5, yes, it is going to be the same number, that is it is going to be -5. So this is very simple with regard to 1 by 1 matrix. Now what will be the case in 2 by 2 matrix? So let us see the determinant of a 2 by 2 matrix. So here we are having matrix A, that is A, B, C, D. So here you can see we are having, this is our row 1 and this is our row 2, this is column 1, this is column 2. So how to find the determinant? The rule is we need to multiply the adjacent sides, that is A into D, and subtract it with the product of the other diagonal, that is B into C. So this is A multiplied by D minus B into C will give us the determinant of matrix A. So here you can see we are having a numerical example. So we are having 4, 2, 1, 2. So this is A, this is B, this is C and this is D. So first is A into D. So you can see 4 multiplied by 2, this is our A into D, and 2 multiplied by 1, this is our B into C. So 4 into 2 is 8 and 2 into 1 is 2. So 8 minus 2 is 6. One more example, if we are having a matrix B, then what is the determinant of B? So here you can see determinant of B is, what I am going to do, AD minus BC. So AD is -1 into -8, -1 into -8 minus what is B? B is 4 and C is 3. So minus into minus is plus, 1 into 8 is 8. Similarly, 4 into 3 is 12 minus 12. So what we are going to get is 8 minus 12 and the value is -4. So this is the negative value of the determinant. What happens if the value is negative? I will tell you geometrically in the next slides. So this is what we get with regard to negative values. Now going ahead friends, let us try to see geometrically how this 2 by 2 matrix determinant is seen. Already I have explained about it in the session when I was speaking about vectors. So here we can say this is our first vector and this is our second vector. So the first vector to get, we need to move on x axis 4 steps towards the right, and then we need to move 1 step towards y axis upwards. So this will give us our first vector. Similarly, for second vector, what we need to do, 2 steps to the right on x axis and 2 steps upwards towards y axis. So this is going to give us our second vector. To make the thing simple, if you take the adjacent sides, then you are going to get this particular type of shape. How this has come and what it is, I have already spoken to you in my session vectors, the previous session. So here friends, this particular shape that has come gives us the determinant. This particular area is the value of the determinant. So what is this shape, friends? We know we are having different shapes in mathematics. One is square, then the other is triangle, the next is rectangle, and similarly this is also one more shape, and this shape is called as parallelogram. So why it is called as parallelogram? Because the sides adjacent towards each other are parallel to each other. That is the reason it is called as parallelogram. So with this understanding, we will go further and try to see how is it that we are finding this particular rule, why it is AD minus BC. So this we will see with little further insight. How do we get AD minus BC? How do we get AD minus BC? So this we will try to understand in a simple way. So friends, this is a rectangle. So if this is a rectangle, first we need to find out is the area of the rectangle. So what is the area of the rectangle, friends? It is area of the rectangle, I will write here only, is length into breadth. So length into breadth. So if I say this particular length is L and this particular is the breadth. So length into breadth gives us area of rectangle. So first what we need to do is we need to find out the area of this big rectangle, and the formula is length into breadth. Now once you have done that thing, next is apart from this parallelogram we need to find out the area over here. So how we need to do it? We can do it simply by dissecting this particular area into different shapes. So how I am going to do it? You can see, first I will divide the bottom part. So this division is giving us one particular shape. So this is our one triangle. Then further dissecting, I am getting a square. So this is my one square. Then this particular area is giving me my second triangle. So what has happened? I need to find out the area of triangle. So area of triangle is half into length into breadth. Then I need to find out the area of the square. What is the formula to find the area of the square? It is simply side multiplied by side. It is side multiplied by side. So this side multiplied by this side. So friends, so here in the bottom part we got two triangles and one square. So the replica is here. You will find the same type of figures or shapes here. So here I am getting exactly, it is opposite to this. So here I am getting my third triangle. Here I am getting my second square, and here I am getting my fourth triangle. So you can see, by taking the entire square of the rectangle, by taking the area of the rectangle and finding out the area of all the four triangles and area of the squares and subtracting it from the area of the rectangle, we will be getting what is left, and that is our parallelogram. So here friends, as I say, these areas I can divide it as again A, B, C, D. So if I divide it like this, so you can see when we are multiplying A into B, half A into B, A into A. So all these things you see, big rectangle minus area of two squares, area of four triangles, all when we do it, then what we get is area of parallelogram, and that is the value of determinant AD minus BC. So in the case of 2 by 2 matrix, when we get AD minus BC, it is nothing but we have got it as the area of parallelogram. So that is what I had told in my first slide, that determinants helps us to find out the volume. And why it is area of parallelogram? Because we are speaking about 2 dimension. What happens if we are dealing with a 3 by 3 matrix? Then we are moving from 2D figure to 3D figure, and this will be understanding in my next session when I will be dealing with a 3 by 3 matrix.